have a Patreon.
Did you see it? In the middle of the screen, what looks like a ghostly apparition appears to scream, "I have a Patreon." Is this real evidence of the paranormal, or just an elaborate ad to get more patrons? You decide. We're finally back, baby. Hello and welcome to How to Create a Horror Game from Scratch. Last episode, we just made it so our enemy can chase us around, but not only that, when he loses us, he goes to the last location he saw us, so that way he can start searching that area before returning to his random pattern. However, today I'm going to teach you how to have a bit more control on the exact locations he's going, and we are going to learn how to deal with complicated AI pathing. You'll see I've made the area a bit bigger here. That's because we are going to be using a lot more control on where we are sending him. But you'll also notice that I left this area blank. So the AI does not think it can go in this area at all. This is to simulate a door being here. I know we actually have a door, but I figured this would be easier to show you what's going on. Because whenever there's a closed door, the AI, the navigation grid, or whatever you want to call it, does this. It does this thing where it just says, well, the AI can't go through there, so I'm just going to say that this is a wall. So before we do anything about controlling his exact movement, let's go ahead and show you this quick tool to correct something like this, or to have the navigation mesh know that it indeed can go through there. Up here at the top left, we're going to go to quickly add to project, and you'll note that we can go down to all classes. And what I'm going to do is start typing in navigation. So just nav will work. And you'll see there's something here called the nav link proxy. I'm going to go ahead and drag that into our scene. Now, you'll note the nav link proxy has two distinct white spheres, essentially, is what those are. And what you're doing is you're basically creating a custom path that the monster can go, or the AI in this case. So normally what you would want to do is have logic in your door or in the monster that, lets the monster open the door. But you would then stick the AI nav proxy in the center like this, and you'll grab each individual white cylinder, and you can see I can move them around, and basically create a scenario where it knows it can go through. Now in this case, obviously I've got it nice and messed up, but I did it on purpose because I want you guys to be able to really see what's going on. So I'm going to make it so he has to go all the way over here. And once he's all the way over here, to get to this nav link, he then has to go along this green path. So obviously this is a weird, convoluted way of doing it, but it'll show you exactly what the monster is doing in order to connect these two navigation meshes. I'm going to go ahead and save, and let's get him aggroed on us. Okay, so he clearly is on us. So now, because he can't go too far this way, what's going to happen is when I jump over to that nav link, he's going to run all the way over to one of the proxies and then run across. Watch. See that? He went to the proxy and then he came over. So that's how the nav point proxies work, is it's saying, hey, from here to here, you can navigate even though your mesh says you can't. And again, the main use case is going to be when you have doors. You'll do something like this, and then you'll want to set up some logic within the monster or the door, so that way he can open it if it is unlocked. So a little bit of a side tangent, but I still think it's really important that I share that. I'm going to go ahead and fix my nav mesh now to cover the whole floor, and we'll get to actually setting up a bit more control over where he goes. Okay, so now you can see he can go everywhere, and we don't have to worry about setting up the nav link proxy. What we're going to do now is we're going to set up patrol points. Basically, we're just going to set up an actor that he can go to. So I'm going to go to Dark BP's actors. And what he's going to do is have these saved, and the behavior tree is going to request the next patrol point and then go to that location. But for now, go into your actors folder. I'm actually going to go ahead and put this in enemies as well. I'm going to create a new folder within enemies. I'm just going to call it patrol in case we end up having additional things that go in there. We're going to right click, and we're going to create a blueprint class, an actor. This is going to be BP_patrol point, and we're going to open that up. With it open, I'm going to hit Control-Shift-S to make sure everything is saved. And within the patrol point, we're actually only going to add things that isn't going to appear in our game world. So I'm actually just going to go up here. I'm going to click Add, and I'm going to type in Sphere. And we're going to add a sphere like this. And on the right-hand side in the details, I am going to type in the word game. And you'll see that we get hidden in game. And we're going to check this to true. And we can clear that search. And I want to see how large this is. So I'm going to compile and save and drag it into my world. I think it's pretty large. Yeah, these are pretty large by default. So I am going to, and this is one of the rare cases we can do this, by the way. I'm going to scale it down. I'm going to go ahead and make sure this lock is on. This makes it so it keeps the same aspect ratio. I know that's not the correct word, but you know what I mean. All these will stay consistent. I'm going to bring this down to like 0.5. I think half will be good. And then compile and save. And then on the sphere, I'm actually going to click add again. And I'm going to add an arrow like that. So now, not only do we have a indicator of the exact spot that he's going to move to, but we have the way that it's facing. And this is important. The reason we want to add a forward vector or a forward visual way to see which way it's facing is because if we want him to get to the patrol point and then specifically look at the forward vector, then that's great. Like, let's say he has a patrol point where he goes up to a window and you want him to look out the window. Well, if you have a forward vector on your patrol point, which you always will, but the arrow makes it very easy to see which way it is, you can set it up and now be like, hey, go to this patrol point, boom, face the forward vector, look out the window. We'll hit compile and save. And honestly, if you want to be super precise, this is not necessary, but like, I could see why you would want to do this. If you click the sphere, right, and you pull it up, so now it's like somewhat in the air. In fact, I'm going to put it at like 50. I think that makes sense on the Z. Then on sphere, I'm going to add, and now I'm going to add a cylinder like this. And I'm going to go to the scale, make sure it's set to locked, and just set this to like 0.25. Or actually, I lied. Leave this on 2, and then unlock it, and set this to 0.25 on the X and 0.25 on the Z. And now you have a very clear indicator of this patrol point and its location. Same thing with the sphere on the cylinder. We're going to have to go over here, though, and type in game. Hidden in game. Boom. Compile and save. And there's one last thing we have to do is, even though the sphere and the cylinder are hidden, they are still currently collidable, which means we would hit these and stop. So up here in search, we're going to type in the word collision. Collision presets, put it on no collision. Then after setting it to no collision, go to custom and just click ignore. And boom, just like that. I guess you don't have to do that, by the way. The reason I started by going to no collision first is because I was like, oh, we'll have to change less. But we don't need to change less because we already have the ignore all button. But anyway, click on the sphere, ignore all, click on the cylinder, go to custom, ignore all, compile and save. And if we look now, boom, look at that. Now you've got these easy to see patrol points that you can set up. I will say though, if you look at where the pivot is, the pivot's like halfway up, which isn't great because technically we're saying move here and that would be somewhere on the Z, like 10 on the Z. See, this is 0 on the Z because the pivot is now on the ground. Do you understand? So what we're going to do is go into our patrol point. We're going to grab both of these. We're going to pull them up so that way they're sitting on 0. Because right now, you look at the grid. The grid is the ground, by the way. We look at the grid. This needs to come up. However, to pull up the ball and the arrow, we have to get them to be not a child of the sphere. Because now if we try to pull the sphere up, it's going to pull the whole thing up. So just take your cylinder, drag it to the default scene route. Do not make it a new route. Just hit attach. And then grab your sphere and pull it to the top. I'll just set it at like 100. Good enough. Pile and save. It'll be a little tall, but now at least these sit on the ground appropriately, and it's not that tall. Okay, so we have a patrol point set up, and it's very easy for us to use and see. Now what I'm going to do is we need a way for our enemy or our monster to have some of these set. And we want different ones set depending on which monster it is. So for example, if our monster is in a certain area, he needs to have different patrol points than, you know, the one in a different area. So I'm going to go ahead and open up our blueprint character enemy. And on the left-hand side, we're going to create a new variable. This will just be patrol points, like that. The variable type will be the BP patrol point we created. Make it an object reference. Right-click this dot to make it an array, and click the eyeball to make it public. Now you can hit compile and save. So now, let's go ahead and create a couple of these patrol points around. You don't have to set up the direction if you don't care, but I'm going to just for the sake of it. And there we go. Now we have 4 patrol points for him to go around to. If we click on our monster, and we go over here to the right-hand side, because we made it public, we should be able to see the default variables, which I think mine, there they are. We can see patrol points, and if you click add, we need 4, because this one has 4 patrol points, and I can just go ahead and add them. Now, make sure you're adding them in the order that you would want him to go around. So I chose this one first, second, third, and fourth. If you add them randomly, he's going to go through them in the way that you put them in. So now we need to set up some logic so the monster can always keep track of the current patrol point that he is on. We're going to go over to the left-hand side, and we're going to add a new function. Oh, by the way, this is the BP enemy. I don't think I said that. I'm just going to call this update patrol point, like that. We're going to create a new variable, and we're going to call it current index. Let's be more specific. I'm going to call it patrol point underscore current index, because you always want to be as specific as possible. We're going to change the type to an integer. We need to right click this to go back to a single reference and not an array, and just hit compile and save. You can leave this at as non-public. And then we need one more variable. We're going to go ahead and create a new one, and we're just going to call it back and forth question mark, and this will be a Boolean, and it does need to be public. Control-Shift-S to save all and compile. So the reason we did the back and forth is because we're going to set this up to have 2 different sets of like ways that it can use the patrol points. If we leave it to false, as in not back and forth, it will go 1, 2, 3, 4, 1, 2, 3, 4, repeat, repeat, repeat. If we set it up to back and forth, what we're going to do is we're going to go 1, 2, 3, 4, 3, 2, 1, 2, 3, 4, 3, 2, 1. Make sense? So that way you can have it set up in 2 different ways. So the current index is always going to be 0 by default. That's a good thing, because in an array, which if you don't know what an array is, by the way, an array is it's a list. And just so you know, an array starts at 0. 0 is the first item on the list, because in an array, whenever you try to pull something out of it, you need its index or address, which is essentially just 0 and then forward, so 0, 1, 2, 3. So whenever we update our patrol point, the first thing we need to do is decide which set of logic we're going to use. And in order to do that, we're going to hit B and click, because we're going to get a branch. And then we're going to plug in the back and forth. Is this set up to go back and forth, or are we just looping? In fact, that's a good thing to put right here. I'm going to right click the branch, go down to node comment, and type in, are we going back and forth, question mark, enter. And we'll hit compile and save. We're going to do the easy one first, which is the looping one. So we are not going back and forth, we are just looping. So it will be false. What we need to do is take our current index, so we're going to do a get, and since we're looping, we need to see if we are as far as we can possibly go. And in order to do that, we're going to take patrol points, and we're going to do a get. We're going to pull out, and we're just going to type in length. So this is the length of the list. Now this is a noob trap you have to watch out for. Honestly, it's an expert trap too. I'm sure they still accidentally have it happen all the time. The length of a list with one thing in it is 1. The address or the index of that item is 0. The length is the current number of items in the list. It can get kind of confusing. However, what we're going to do is we're going to take our current point index. We're going to add 1 to it. Okay, so that means that now what we're doing is we're saying take our current index. So like, let's say there's 1 item in it. So our current index is 0. And we need to see if we are at the end of the list. So we're going to do a greater than equal. You could just do an equal here, but the greater than just kind of adds some buffer, some bug catching in case you accidentally go above the length of the list. Shouldn't happen, but that's why we add the greater than. So what we're going to do is we're going to add 1. Sorry, I forgot to put 1 there. We're going to take our current index, which should be 0 because we're pretending there's 1 thing in the list. We're adding 1 to it, so now we're at 1. So is our current index plus 1 greater than or equal to the length of the array? Because if that's true, we need to reset and go back to the beginning of the list because we're looping instead of going back and forth. So let's hit B, get another branch. Let's plug our false into that branch, and the condition will be the greater than or equal to our index plus 1 and the length. So for the branch, I'm going to right click it, go down to the node comment, and I'm going to type in, are we at the end of the list? Or you could say end of array if you want to be specific. So let's say we are. Let's say we are officially at the end of the array. Well, all we simply need to do is set our patrol current index. So go ahead and set it. We're going to set this back to 0. So I'm going to right click this and just say, go back to beginning of list, just like that. But if we're not at the end of the list, that means we just need to increment our current index by 1. So in order to do that, we're going to take our current index, and what you can actually do is pull out, and instead of typing add, just type in plus plus, and you'll see we have increment integer. This adds 1 and sets this in one node. So not only is this going to add 1 to this variable, it's going to save it too. All right, so if we're at the end of the list, go back to the beginning. If we're not at the end of the list, go ahead and add 1. All right, but what if we're going back and forth? This is where we're actually going to go ahead and add an additional variable. We're just going to put back on this one instead of back and forth. This one can remain a Boolean and it does not need to be public. It also needs to go ahead and be default false, which it should already be that by default. So I need an additional branch. And we're going to plug our true into this. So are we going back and forth? Yes. However, is this currently a situation where we're going back? So right click. Are we going back? Control Shift S, compile. All right, so are we going back? Well, if we are, then what we need to do is get our patrol point current index, and we simply need to see if it's less than or equal to 0. Because if it is, then we know we're at the beginning of the list. The reason we don't need to change the value is because in this case, we don't care about how long the list is. We simply need to know if we're at the start of it. And in this case, since we're using an index, all we need to check for is a 0, not 1. Remember, we're not dealing with a list. We're just simply dealing with the address at this point. If it's a little confusing, I apologize. Go ahead and plop the branch down. And we will say, are we going back? Yes. Okay. But are we at the beginning of the list? And we'll plug that into our condition, move it over. Because if we are at the beginning of the list, then all we simply need to do is take back and set this to false because we are no longer going back because we've hit the beginning of the list. And then increment our index because we're going back and forth. So since we are at the beginning, we're no longer going back, and we're going to go forward a step instead of backwards a step. Control-Shift-S, compile. If we're going back and we're not at the beginning of the list, we're going to take our patrol point current index, and instead of plus plus, we're going to type in minus minus, and that will de-increment the integer, just like the increment, but obviously the opposite. Compile and save. And then the very last branch that we haven't messed with yet is, are we going back false? So if we're not going backwards, then that must mean we are going forward. So we need to do a similar check to this right here. Let's go ahead and copy it, paste it, put down a branch, bring our false over to it, plug our condition in. I'm going to right click on the branch, describe our condition. Are we at the end of the list? So if we are at the end of the list, we need to set back to true now. And we need to take our patrol point index. I'm going to just copy and paste it from above and de-increment it. If we're not, then we will just increment it. Copy, paste, plug that into the false. And it's a little close together, so I'm going to go ahead and use the space provided to me. It's good to use as much space as you can to make this a little more clean. Plus, when you use the space, look how much easier it is to see the differences. So, for example, we can take a look and say, are we going back and forth? Are we going back? So this would be going back. This one is going, I'm going to say forth, so that way it makes sense, like going back, going forth, right? And then on this one, I'm just going to type in looping, and there you go. Now we have our logic. So we're going to call this function anytime we want to update our index. In fact, what we'll do is at the end of all of these, we'll add a return node. So that way we can do this in one function instead of two. So I'm going to right click, I'm going to type in the word return, and I am going to drag. So for example, from our increment, I'm going to drag that straight into the node so it easily makes the variable for me. And on the right hand side under output, I'm just going to call this current index and hit compile and save. And now at the end of each of our possible branches, we'll take our return node and we'll return our current index. This is so whenever we call this function, it will automatically retrieve the information we need and send it to whoever is calling it. You'll see what I mean in a minute if you're not following along. So there you go. I added 6 return nodes because each possible path has 2 outcomes. And then I'm going to hit compile and save. And now what we need to do is we need to be able to call this function and have it return the information to the blackboard. So I'm going to go ahead and hit control space, and I'm going to open up the behavior tree. So currently we've got move around randomly. We've got aggravated and chasing us, and then we have aggravated and not chasing us. So instead of it being random, we're going to create a new task. So what I'm going to do is actually just delete this, and we're going to make it so it does a patrol instead. So let's go ahead and hit save. Then I'm going to go up to the top. I'm going to click on new task, BTT task blueprint base. Open up our tasks folder. Delete all of it except for the BTT task underscore. And I'm going to name this request patrol point, and just press enter. Remember, with any task, the event we need is event receive execute AI. This is the thing that gets called whenever the task appears on the behavior tree. And now, in order for our task to communicate with our pawn, we have an interface for that. So let's go back to our dark BPs, or I guess that's what mine's called. Go back to your BP folder. Let's go to interfaces, and we need the one that talks to our pawns. So let's go ahead and open up BPI pawns, and we are going to add a new function, and this one's going to be called request patrol point. And we're going to need an output for this. So we're going to click plus on the output. We're going to call this patrol point because this will be the returning patrol point. And the value will just be the BP patrol point we created as a object reference. And then we'll hit compile and save. Back in the task, we will go to our controlled pawn, and we are going to send them BPI patrol or request patrol point, and that will be a message like this. And as you can see, because we had an output of a patrol point, we now have access to the patrol point that's coming in. And what we're going to do is we're going to, out of patrol point, we're going to get actor location. And out of our execution pin, we are going to type in get random location and navigatable radius. Now, I know that sounds bad because it's random, but what we're going to do is get that actor location, and that'll be the origin. And then the radius, we can just put something like something small, like 15. And what that's going to do is it's going to say, you might not be going to the exact location because maybe I placed the pawn or the patrol point in sort of a weird spot. So what this does is, yes, it's got like a 15, like wiggle room of 15, but it's going to always return something that it can reach. So it kind of saves us from errors. I hope that makes sense. Then what we're going to do is on variables, we are going to create a new one. We're just going to call this target location, like what it's called on the blackboard. And I'm going to make this or not a vector, sorry. This is going to be a blackboard key selector. It does need to be public. And then for random location, we're going to pull out and we're going to do set value. So set blackboard value as vector. The key will be that target location variable we just created. And then we will finish, execute with a success, and we'll hit compile and save. Let's take a look at it one last time. We're going to request a patrol point. We're going to get its location. We're going to get a random location in navigatable radius, as close to it as possible. And then we are going to get that value as a vector on our blackboard, and we are going to finish the execute. So let's go ahead and compile and save. And now we'll go back to our behavior tree. And whenever we're walking around, what we're going to do is the first thing we're going to do is we are going to request a patrol point. And you'll see that we have target location, self actor. So that's wrong. What we need to do is have target location be target location. Again, these names don't have to be exactly the same. It's just really easy to remember what you're doing whenever you do that. So we're going to get a target location and set it. Then we are going to move to, right now it's set to self actor. So no, we want to move to target location. And then we will wait. So we'll sit there for a second. So we'll leave it at like 5 seconds with like a random deviation of like 2 seconds. So between 3 and 7 seconds. Control-Shift-S to save it. Awesome. So let's think about what we have set up so far. We have logic to go through the list of patrol points, either forward and back or loop. We have a task that is retrieving a patrol point, and we're getting a place to go near it. And in our behavior tree, we're calling that task that way to set up the target location and then move to the target location. However, the piece we're missing now is getting the patrol point to the behavior tree. But if you remember, BPC enemy has the interface implemented, the pawn one. So as you can see on the left-hand side, we can request a patrol point. So if we double click on request patrol point, so now we can set up some logic to send the next patrol point. So anytime it requests the patrol point, the first thing we want to do is update what patrol point we're on. In fact, I just thought of a problem with my logic. Let's hit Control-Shift-S and I'll explain what I did wrong. In fact, if you know already and you want some brownie points, leave a comment right now. However, it's not something that's probably easy to think of when you're new, so if you can't think of it, it's fine. We actually need to set the current index to a default of -1 and hit compile and save. You're probably wondering why. A list cannot go to -1. Well, because the first time it requests a patrol point, it's immediately going to increment it 1. Because by default, we're not going back, and by default, even if we're looping, it doesn't matter. Like, we're going forward, so no matter what, it's always going to set it to 0 with our current logic whenever we update patrol point. Because if it's set to 0 by default, as soon as it runs update patrol point, it's going to immediately go to 2 and it will skip the first patrol point. Does that make sense? Are you following? So we just set the current index to -1 by default. The behavior tree requests a patrol point. We update our index to whatever's next. We get our list of patrol points. And out of it, we're going to just type in the word get. A copy is fine. Take our index, plug it in. So now we are going to, like, let's say this is the first round through. So -1, update patrol point. We're at 0. So get 0 or the first thing, because 0 on the list, and return it in the return node. So now let's follow the logic. We'll start here. The behavior tree runs this task. This task requests a patrol point. Our enemy gets his next patrol point and sends it back. We now have the patrol point, so we're going to get its location. We're going to get a random location navigatable radius and a very small radius of the origin, so that way it's making sure it's somewhere we can go. We're setting that location as a vector on the blackboard, and we're finishing our execute. We're taking target location, setting it to target location, then we're moving to target location. We wait, and the whole process starts over. I hope this all makes sense. Let's hit Control-Shift-S and go back to our house map. Now, right now, it is not set to go back and forth. The monster is set to loop through every single one of these patrol points. So what I'm going to do, so we can test this, is I'm actually going to go back to the enemy. I am going to go over to the left-hand side, or actually, no, we'll go to the event graph. Or no, it's not even the event graph. It's the AI controller. I'm actually going to disable his perception, so that way he doesn't chase us. So we can test this. And if this works correctly, he will now patrol through all 4 of the patrol points instead of randomly. So there you go. He's at the first patrol point. If you remember, he'll now wait between 5 and 7 seconds. He'll update his patrol point. He now has made it to the second patrol point. He should be able to make it all the way over here. Fantastic. He's coming around. Bam. And if our logic works, he'll go straight back to the first one. And there he goes. Awesome. So I'm now going to set the wait time to like 1 second and make it so he loops. Be right back. I said loops, but I meant back and forth. So let's go ahead and set this to back and forth. And I reduced the wait time so we are no longer waiting for him at each point. Hit play. It's set to back and forth. We're going to check our logic. We're going to make sure that he goes all the way through. And instead of looping back to 1, he returns to the patrol points in a back and forth fashion. So he's at 4. And look, he's going back to 3. Look at that. So now you can not only have him walk around randomly if you'd like, you can now have him move between specific patrol points in either a looping or back and forth fashion. I hope you guys enjoyed this video. My life has been very stressful, so if this one's not as of good quality or my explaining is a little bit worse, trust me, the video where I explained the death of my wife's mother was just the tip of the iceberg. It hasn't stopped yet. I'm losing my mind. Regardless, I appreciate you guys. Your kind comments are keeping me going. I hope these videos are still helpful, and I'll see you in the next one.